All right. Don't have to do a random drug test then. All right, guys. Are there any questions on any of the assignments thus far? Any questions on any of the homework assignments thus far? It's going to be possibly Thursday, depending on how 3-6 goes. Thursday?
That's junior skip day. Wait, that's senior skip day? No, junior skip day. We don't care about seniors. Oh, I'm going to the senior skip day and I'm not even a senior.
Let's look at this here. Now, what we're doing today is completing the square. We did this some yesterday. We did 2 problems like this yesterday. We're going to do a few here today, depending on how we feel with this here, guys. Now, there were 4 main steps in completing the square. The first is A equal to 1. If not, make it so. Step 2, get the variables on one side and the constant terms on the other. Step 3 was to find C, which is equal to B over 2 squared, and plug in. And the last step was to factor and solve. These here are the main 4 steps in factoring, or not factoring, in completing the square. Is anybody still? Yeah, that's it. If not, make it so. If not, make it so. Let's look at the first one here. Let's look at the first problem. X squared minus 16x plus 64 is equal to 100. Now, we solved this one yesterday. We went on and already solved this here. Now, the way we solved it yesterday is we went on and just factored x squared minus 16x plus 64, and it worked out to be a perfect square trinomial. Now, I want to go on and solve it again. We're going to solve this one here again. But say we did not notice that this here was a perfect square trinomial. So we're going to go through the steps of using completing the square. Yes. Now, when we look at this here, x squared minus 16x plus 64 is equal to 100. The first step in completing the square is a equal to 1. Because our general equation for this is ax squared plus bx plus c. So a is in front of the x squared. Is a 1? Yes, if we don't write a number in front of it, it is understood to be 1. So A is 1. So that was the first step. The second step was to get the variables on one side and everything else on the other, the constant terms on the other side. So we would minus 64 from both sides. Because 64 minus 64 is 0. So we have x squared plus, not plus, minus 16x plus blank is equal to, well, 100 minus 64 is plus blank. And again, we're leaving those two blanks in there because, again, we want this to be a perfect square trinomial. We wanted to make it into a perfect square trinomial so that I can rewrite this side as a set of parentheses squared. That way we can take the square root of both sides and solve. Now, before we can get there, we need to find the value of C that will make this into a perfect square trinomial. And to get that, we're taking B divided by 2 squared. Will give us that C value. Now, in this case here, the value of B is negative 16, because we take the sign 2. Well, negative 16 divided by 2 is, and negative 8 squared is 64. So the value of C is, so we need to add it to both sides. And what goes inside the parentheses is, so we would have x minus 8 squared is equal to 100. And yes, that does look odd because, again, what did we say x squared minus 16x plus 64 was to begin with? A perfect square trinomial, yes? Since it was one to begin with, well, the number that we add back in would be 64, and it would have factored. If we'd have noticed that this was a perfect square trinomial, we could have come straight down to this step and not have to do the in-between. But that's just because the one side is already a perfect square trinomial. It works out that way. But even if we did not notice that it was one, the steps still get us to where we need to go. They don't change. Now at this point here, we would square root both sides. Well, here the square root and square would cancel, leaving us with x minus 8 is equal to plus or minus 10. And then we would add 8 to both sides, telling me x is equal to 8 plus or minus 10. Well, again, they're just two numbers. We can do 8 plus 10 and we can do 8 minus 10 and get a number, yes? Eight plus 10 is 18. 8 minus 10 is negative 2. Now, we did do this one yesterday, and we got the same results. Now, we don't have to do the plus or minus, break it up, if they are not able to be added or subtracted. Because if it was 10 square root of 2, well, we can't add 8 and 10 square root of 2. They're not like terms. Or if it's dealing with I. If I have 10i, well, I can't add 8 or subtract 8 and 10i. They're not like terms. But here, since we have two numbers, 8 and 10, well, we can do 8 plus 10. We can do 8 minus 10. We need to find both. We'll only add and subtract if we can actually add and subtract. If we can't, we'll just leave it. Any other questions on this here? This one here, we're not going to actually go through and solve because it's the exact same thing as this first one because, again, x squared minus 6x plus 9 is a perfect square trinomial. And we can see that because if we found C, b over 2 squared, well, b is negative 6. Well, negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. Well, where do you have the positive 9? It's just factoring that down and using the square root method. Because what I want to really look at is this one here for sure. Some that is actually using the square root method where we don't end up back to where we started. So when we look at this here, first step in the square root method, is a equal to 1? Yes, because we're talking about the number in front of x squared. Well, here it is 1. So, okay. That was step 1. Step 2 is to get the variables on one side, everything else are the constant terms on the other. So to get the constant term on the other side, we would subtract 8 from both sides. And what that would leave us with is x squared minus 4x plus blank is equal to negative 8 plus blank. Because again, we leave those blanks in there so we can fill in the value of c. We want to find out what number is going to make this into a perfect square trinomial. Well, our c term is defined by what equation? B over 2 squared. B over 2 squared. And our b value would be negative 4. Well, negative 4 divided by 2 is negative 2. And negative 2 squared is 4. So we're going to plug 4 in here and here. Any questions on this here so far? When we factor x squared minus 4x plus 4, well, we're going to have x what? X minus 2. Because again, the number that we have before we square it will be the number that goes into the parenthesis. Is equal to negative 8 plus 4 is? And last but not least, what do we need to do? Square root both sides. On this side here, the square root and square would cancel, leaving us with x minus 2 is equal to plus or minus. Well, the square root of 4 would be 2. The negative would come out as. So the square root of negative 4 is 2i. We need to do one more thing because we need to get x by itself. We would add 2 to both sides, which will tell me x is equal to 2 plus or minus 2i. Is 2 and 2i, are they like terms? No, we can't add or subtract those, so we are done. Well, since I know that I have complex terms, could I solve this by graphing? Could we solve this one by graphing? Well, no, because this here would be one where the graph does not cross the x-axis. It's our no real solutions. Because 2i is not a real number. So this here is not a real solution. It is our complex solution. So we can't solve it by graphing. We can't really solve it by factoring, but we can write it as two factors being multiplied together. It just works better if we get to the answer and then show the factors than trying to work the other way around. By starting with the equation and then trying to find the factors. So here, because it is imaginary solutions, completing the square is going to be the best, really only method that we have to solve it. Any questions on this here? How do we feel about completing the square? You feel good with this here? Okay. Let's look at this one. Example 4, because it should be the one after the one we just skipped, number 8. What is different in this one here than the one we just did. A is 3, yes? A is not 1. Because our first main step in solving this is what? Is A equal to 1? If not, make it so. And exactly, here we have 3, A is 3. But we need it to be 1. So what can I do to make the value in front of x squared be 1? We would divide by 3. Is 3 divided by 3 is? Now we have to divide every single term by 3. Now 3x squared divided by 3 would be 1x squared. 12x divided by 3 is? And 15 divided by 3 is plus 5 is equal to 0. Now the first thing I would do is I would try graphing this to see if it does give us solutions. Because if it said to solve this by any method, we could solve it any way we want, I would start off by graphing. Because if it turns out that the answers are whole numbers, the graph will give it to us. If that doesn't work, I would look into seeing does it factor, just seeing what are the factors of 5 and see if I can manipulate them and whatever the factors in front of x squared are to see if I can get to the middle term and try factoring it. And if neither one of those work or it doesn't look like it'll factor, completing the square will always work. Graphing doesn't always work. Factoring doesn't always work. The square root method, well, if we're really delving into the square root method, we might as well be doing this here if we actually have a middle term. Now this here will not graph, it will not factor. But we do have A as 1. So now we can move on to step number 2, which is to get the variables on one side and the constant term on the other. So we would subtract 5 from both sides. And if we subtract 5 from both sides, we're left with x squared plus 4x plus blank is equal to negative 5 plus blank. Now the value of c is equal to b over 2 squared. And what is our value of b? That's 5. Because this is referring back to ax squared plus bx plus c. D is always going to be in front of the term with x. And we need to make sure all the x's to the first power are on the same side, all the x squareds are on the same side. So here the value of b is positive 4. Questions on this here? Does that make sense? It's not going to be 12, because I did get 12 in previous hours, guys. Because at the start of the equation, 12 was our value of b, yes? But what did we do to every single term? We divided it by 3. So our new value b is 4. So we wouldn't look at that because we divided everything by 12. Now we do need to simplify this. 4 divided by 2 is? And 2 squared is? The one after 8. Almost. Now this here, we'll have our set of parentheses squared. We would have x plus 2. Since the 2 inside the parentheses is positive, we would put plus 2. Squared is equal to negative 5 plus 4 is? What do we do next? Square root both sides. Now the square root and square will cancel, leaving us with x plus 2 is equal to plus or minus. What is the square root of negative 1? Because by definition, the square root of negative 1 is I. I is the square root of negative 1. Is x by itself? We still have the plus 2. So we do need to subtract 2 from both sides. To get x by itself, x is equal to negative 2 plus or minus I. So our final answer is negative 2 plus or minus I. You're good? Any questions on this here? So this here, there is a lot of little steps. And that's what can make completing the square challenging, is just remembering each and every single step to do. Because if we don't get rid of the value of a, if a is not 1, that's going to throw everything off. We have to have the value of a equal to 1. Then we've got to move the constant term, find the value of c, rewrite it as set of parentheses squared, and solve. Any questions on this here? We are going to look at one more, but I feel like these here y'all feel comfortable with. I realized this morning as I was looking at these, this is not going to come as any surprise probably to most of y'all, I didn't find these to be too interesting. Because here the value of a is, well, negative 3, yes? 18 divided by negative 3 is 6. Yes, it comes out to be nice. 32 divided by 4 is 8, yes? So I added this one. So I added it, it's not on the note sheet. I went on and added this here. Because this is technically one of the drawbacks to completing the square, is if there's a value of a that is not 1, and the rest of the terms are not divisible by it, we're going to have to deal with fractions. So let's see how this works. Well, this one here, a is not 1, it's 2, so we need to divide everything by 2. But that's not any different than what we just did. 2x squared divided by 2 will be x squared minus, well, 5 is not divisible by 2 evenly. It is divisible by 2, we can get 2.5. But because it's not even, because we don't get an even number or a whole number, we're going to leave it as a fraction. Same with 67/2. It does not divide evenly. And 0 divided by 2 is 0. Now the next step was to get the variables on one side and the constant terms on the other. So we would subtract 67/2 from both sides, which will tell us that we have x squared minus 5/2 x plus blank is equal to negative 67/2 plus blank. What was the next step? We had to find the value of? Well, c is equal to b over 2 squared. What's the value of b? Negative 5/2. So we need to take negative 5/2 divided by 2, which is negative 5 over what? 4. Well, the last thing we need to do is we need to square it. Well, a negative number times a negative number would be positive. 5 squared is 25, and 4 squared is 16. So we have 25 over 16 and 25 over 16. Because this non-divisibility of 2 with B and C really made this problem any harder than the ones we did before? No, it's just we're dealing with fractions. That's the only real change. Now the next thing we need to do is rewrite this as a set of parentheses squared. That's going to be x minus 5 halves, because what we had inside the parentheses before we squared it was not 5 halves, sorry. It's not 5 halves, it's 5 fourths. Because what's inside there will be 5 fourths, and since it was negative 5 fourths inside the parentheses before we squared it, it's going to be x minus 5 fourths. Now we need to do, or simplify down negative 16 halves plus 25 sixteenths. We need to add those two together. Well, the calculator will do it for us. If we had to do it by hand, we would have to change negative 67 halves into sixteenths. We need to change the denominator to sixteenths so that we can add the numerators. The denominators have to be the same when we add or subtract fractions. So we'd have to multiply 67 halves, negative 67 halves, by 8 on top and bottom, so that we both have a denominator of 16. And once we do that, we would combine it, telling us that it's negative 511 sixteenths. I didn't do that in my head. I calculated that this morning. But what do we do next? Square root both sides. Well, here the square root and square will cancel, leaving us with x minus 5 fourths is equal to plus or minus. By our properties of radicals, we can take the square root of the top and bottom separately. Well, what is the square root of 16? Yep, because 4 times 4 is 16. Now in the numerator, we know that the negative will come out as I. For any radical, if there's a negative inside the radical, it's going to come out as I. That leaves us with the square root of 511. Now the graphing calculator is going to give you a decimal most likely. The yellow calculator will leave it in simplest radical form. If we type this into the TI 30XS, it'll tell us that the square root of 511 is the square root of 511. It doesn't simplify. There are no products, two numbers that multiply together that give me 511 that are perfect squares. So we get those here. Well, we still need to get x by itself, so we can add 5 fourths to both sides, which tells us that x is equal to 5 fourths plus or minus I square root of 511 over 4. Well, really, since the denominators are the same, we can rewrite it on the same. We don't have to split it up. We can write it as one term. Oh, apparently I'm going to throw that. Since both denominators are 4. Any questions on this here? Any questions on anything we've done so far? But that's it. That is all we're doing for today. So your homework is this here. Now tomorrow, we will be going over the quadratic formula. The quadratic formula is the last method we will go over for solving quadratics, and is the other method that works every single time. Completing the square and the quadratic formula are the only two methods that work for every single quadratic equation. And it works out that completing this, well, the quadratic formula we can get it from completing the square. Since the completing the square works every time, if we can find an equation or formula from using it or by using it, that one should work also.